Problem 14 says, using washer method, find the volume of the solid obtained by rotating the region bounded by y equals square root of x plus 3 and y equals x plus 3 around an axis of y equals -1. So in this case, it just says to use washer method. So we know that for washer method, volume is equal to pi times the integral of r outer squared minus r inner squared. Now, we'll need to figure out what our outer and inner radius is, but the first step that I'm always going to do is I'm going to figure out whether we're dx or dy in this case. So if I look at this shape, I have a sliver that I'm going to take and I'm going to rotate it this way. So because I'm doing disk method, I want it to be perpendicular to my axis of rotation. Because this is perpendicular, and because this is going up and down, that would mean that it would need to be dx. So dx is what I'm going to be integrating with respect to here. Which means that all of my terms that I plug in for my outer and inner radius need to be with respect to x. Okay, so now I need to figure out what my outer radius is and what my inner radius is. Well, my outer radius is just going to be the square root of x plus 3, because that'll be like the parabolic shape. Y equals x plus 3 is just a straight line. So I know that if I go top minus bottom, this is my r outer, and this is my r inner. Okay? So now that we know that, let's go through and let's see if we can actually get a definition for r naught. So we have to be careful because it's not centered, we're not rotating about this space here. We're not rotating about the x-axis. We're rotating it about y equals -1. So what that means is that my r outer is actually going to have to be square root of x plus 3 minus -1. So what I'm going to have to do is, because I'm offsetting it by this amount, I'm going to have to subtract off this extra radius, which because it is a negative value, it actually ends up adding into it. So what my r outer is my r outer is actually square root of x plus 4. Same thing with my r inner. If I subtract off -1 from here, I end up getting x plus 4. So these are my new r outer and my new r inner. And that's what I'm going to plug into here. The other thing I need to do also is I need to figure out what my boundaries are going to be so that I can integrate them over. But I'll do that in the very last step. So for now, let's go ahead. Let's plug everything in. So my r outer is equal to square root of x plus 4, quantity squared, minus x plus 4, quantity squared, dx. So I can go through and I can factor some of this stuff. Volume is equal to pi integral. So I'm just going to FOIL this out. Square root of x times square root of x is just equal to x. 4 square root of x plus 4 square root of x, that's equal to 8 square root of x plus 16. Minus everything in here, which is x squared plus 8x plus 16. And I have a dx outside. Great. So now my volume is equal to pi times the integral. So I can simplify some stuff here. I have an x and I have a minus 8x if I factor this in. But actually, I'm going to write it in descending power order. So my first term is minus x squared. So that's what I'll start with. So that takes care of that term. I have a minus 8x and a plus x, so that's minus 7x. And then I also have a plus 8 square root of x, which doesn't simplify with anything. Then I have a plus 16 and a minus 16, so these terms just cancel out. And then I write my dx on the very end. So good, I have my expression for it, and it looks like it matches with E, but just to be safe, I'm going to check my endpoints, and I'm going to figure out what my boundaries are going to be for this integral. So the way I do that is I take my two curves and I set them equal to one another. So I have square root of x plus 3 is equal to x plus 3. The 3's cancel, and I'm left with square root of x equals x. So what that tells me is that if I have x minus square root of x equal to 0, I can solve this system. So I can pull out a square root of x from both of them. And that will leave me with square root of x minus 1 is equal to 0. So if I set these two solutions equal to 0 and solve for them, I end up with x equals 0 and x equals 1. So those are my two boundaries in this case, 0 to 1. 0 to 1. So therefore I have my full expression for the volume. And that matches with letter E.
The Teaching Center, UF's Learning Resource Center.